word break 2 solutions is very similar to word break 139 solution. This is just to satisfy the 3 steps that I was talking. Pull the node first and then the validation and then processing. Okay. Hello guys, welcome back. Today we are going to solve this hard problem from Leetcode, word break 2. In my earlier session, we have already solved word break in DFS and memoization and also using DP. If you have not watched that video, you can go and watch that again, because I am going to use those concepts here again. So we are going to solve this word break 2 problem using BFS, breadth first search. Okay, word break 2 solutions is very similar to word break 139 solution. So that's why what I'm going to do here, I will be solving 139 word break problem again here using BFS, and then we'll solve word break 2. Okay, towards the end of the video, actually I will revisit the same problem using DFS again, because this is requested by one of my viewer, Anand Tripathi. He wants word break 2 with DFS, but we will start with BFS first. Okay, so let me go ahead and copy the DFS solution. We'll modify that DFS solution a little bit to make it a BFS solution. Okay, instead of writing it from the scratch. Fine. Now let me call this BFS. Okay, BFS. Let me write to do here, otherwise people who are starting from the middle of the video, usually no one wants to see the approach. I know, okay, people don't see the approach in the video and they just go ahead and see the final solution and they think that okay, I am done. That is not how you should watch these videos. Watch my video step by step, otherwise you will be missing a lot of techniques that I talk about in my session. In the BFS approach, what we do, we use a queue first thing. Okay, in the DFS approach we use stack, right? So right here I am going to use a queue BFS approach, and again it is iterative solution. Okay, like the DP solution, right? So let's get rid of this set. I'll be removing this code as well. Okay, and this code as well. Okay, so let me remind you again that we are using the start index to tell the code that our next substring that we are going to process is starting from the start index, right? And that is helpful in the recursive call, right? And we are not going to use a recursive call here, so let's get rid of this also, but that concept we have to use here. Okay, I will remove this as well. Yeah, so if you remember the DFS method, we were passing ith index as a start index to our next DFS call, right? If we would have solved that DFS approach using a stack, then what would we push to the stack? We would have pushed the variable which is changing, right? So the only variable which is changing here in the entire process is I, index. Okay, so the index we are passing for our next processing, right? So yeah, we'll be passing the same index to our queue. So let's initialize our queue. Integer, I'll say queue. Okay, I'll just write queue here, new array dq. Okay, and now the first index that we will be processing is the 0th index, right? From 0 index we will be processing, right? So q dot offer 0. Okay, now what will we do? We will write a while loop. We'll check if q is not empty, empty, q is not empty, then we'll start processing this, right? BFS or DFS, what we do, we usually do 3 steps only, right? We push the node to the queue, push the information to the queue or push the information to the stack, then pull the node or the information from the stack, then we do validation, we check whether we can process that node or not, and then we process the node, and then we push to the queue or the stack again, right? So that's what we're going to do here. Okay, so first step in the queue. Okay, let me just close this first. Okay, this is for loop, this should be closed here. Okay, now first thing first, pull the information first, pull the node first, right? So integer start equal to q dot pull. Okay, now we have the information. Okay, now once we have the information, what we do, we start processing it, right? Which we are doing it here already in the for loop, right? So in the for loop, what we are doing, we'll start processing from I equal to start plus 1. For this particular case, we started with 0, we polled 0 here, and I will start from 1. Okay, so which is actually satisfying the condition, right? Now we'll see string left equal to substring start I, so 0 I, which is the left substring we got. Okay, and we'll check if the left substring is in the dictionary. Let's say yes, and then in the case of DFS method, what we are doing, we are passing the right substring to get processed again, right? Here we are dealing with a iterative approach, right? So instead of calling this method, what will we do? We'll push this information to the iterative stack or the queue, right? So let's get rid of this code, okay, and we'll say queue dot offer I. Okay, so if left part, if the left substring is present in the dictionary, we will push the index, we will enqueue the index I in our queue, okay, so that it will be picked up in the while loop, okay, and again processed. Okay, we cannot return true here anymore, so we'll remove this. At some point I will be s dot length and the right substring will be empty, and that was our terminating step. If I will be equal to length, then we don't have to push that index anymore to the queue, right? So we can actually do it here. So if dictionary contains left, this is fine, and now if I equal to s dot length, this is the terminating step, right? Then we can say return from here, return what? True. Yeah, this is fine. Let's just give a tab here. Okay, yeah. So if you see this solution, we are almost done here. We just have to skip these substrings which are already processed. So what will I do here? I will just create a boolean array, okay, and I'll call it visited, okay, new boolean s dot length size, okay, and I'll check if visited start equal to true, right? If we have already visited that index, then we'll return from here. Actually we cannot return, we'll continue, we are going to skip that, okay, so continue, okay, and after this, if it is not visited yet, then we can say that visited start index equal to true. I have copied the solution to Leetcode. Let's just run it. Okay, now submit it. Yeah, let me copy this code because I am going to use the same code here for solving word break 2. Okay, just little bit of small modification we'll do and we'll see this solution. Okay, we are given a string and dictionary of strings. Add spaces in S to construct a sentence where each word is a valid dictionary word. Return all such possible sentences in any order. These sentences are nothing but containing all these substrings which are actually, you know, part of the given string. Okay, so yeah, so in this case, so for one index we have to remember all the possible sentences that we have formed so far. Okay, so for one index, how many results we have found so far, so we have to remember them. Okay, so I'm going to modify the information that we are passing to the queue. This cannot be integer anymore. What we can do, we can actually use a node class, or we can actually push two information as a object also, object array also. Okay, and then we can, you know, typecast and we can handle them. Okay, I sometimes prefer to use array than writing a node class because I think we have to type less while using an array than writing a class. Okay, in the interview, as long as you can communicate that information to the interviewer, I think any approach is fine. Okay, so let's go ahead and create a new node here, node class. Okay, class node int index to hold the index, and then string step, I'll call it step because we are actually keeping the result until the index I. I'll create a constructor which will take two params, okay, and this dot I, this dot index, right, this dot index equal to I, this dot step equal to step. Instead of object we'll pass the node here, so queue of node, I'll pass new node 0. For 0 the step or the result will be empty string, right. So we'll start with an empty string, right. Fine. After that this is fine, then we'll go here, okay, here, okay, when we poll we'll be actually getting a node, right. So we'll start with node, okay, node, I'll call it temp, okay, and then go here, and instead of start temp, fine, and then we are actually checking with start, so instead of start I'll say int start equal to temp dot index, right. This is our start and we are dealing with start here. This is fine, this is fine, this is fine. This is looking a little clumsy, just give some spaces, okay, because I'm going to insert some code here, okay, and this is fine, okay. Let's just call this temp to node, okay, instead of temp, node dot index, node start index, fine, okay, fine. Now dictionary contents left, this is fine, okay. So now in this particular step we get the left substring, right. Here if you see we are actually forming a string, right. So we are getting substrings and we are appending spaces and we are forming the string, right. How will we form the string? We are going to append the left substring and the result, okay, whatever we have so far. So here what will I do? I'll create a string temp equal to node dot step result, okay. So until now whatever I have with me, okay, I'm going to append that with my left substring, right. So I can say now temp equal to the node dot step, right, the result, the node dot step, okay, plus what? Plus the left substring, right. So we can say space plus the left substring, okay. Okay, let me give you a simple example, okay, InterviewDose, okay. Let's say there are two words, okay, interview and dose, okay. Let's say we have already processed interview, okay. So now we have in the queue, because we are saving two information, in the step string we already have interview, and now when we say substring start I, at some point we will be actually looking at dose, right. So what will we do? To form the full sentence, temp equal to node dot step, which is interview, plus space and the left will be dose, right. For the case when node dot step is empty, like for the first case, okay, we just have to pass left in temp, right. If node dot step is empty, then we don't have to append this space, right. So we'll check if it is empty, then we'll say temp equal to left, and if it is not empty we will append step, right. The prefix will be step with a space, right. So yeah, so now I can write this temp here, right, temp dot step here, okay. So now if you see this line, you can see that the temp is nothing but our sentence which is getting formed whenever we see the left substring is already in the dictionary, right. So now because we have some result, we have a result for the index I, so I can say queue.offer new node I with the temp result. We cannot return here because we are still processing to find all the possible sentences, right. So what I can do here, I can say actually I have not created a result list that I am going to return. So let me just create that list of string result equal to new array list. Okay, and this result will contain all the possible results, all the possible sentences. Okay, here I can say temp result dot add temp instead of returning true here, and return result. Okay, we have to include all the possible sentences which can be formed, right? So we cannot just ignore the substring which are already visited. So let's get rid of this. Okay, and I'll get rid of this also. Okay, and yeah, this is fine. I think this is fine. Let's run, and now submit. Cool, nice. Fine, now let's do a small modification to the BFS problem. This solution is alright. I just wanted to move this part, the validation part, actually the termination step, to outside the for loop and right after the node is pulled. This is just to satisfy the 3 steps that I was talking, where I do pull the node first and then the validation and then processing. Okay, so we don't have I here, rather we have the start index. If start index equal to length, then we add the result, and temp is not here, we have the node and step, right? Yeah, let's now run. Accepted, and now submit. Actually it is 4% faster. Okay, which is good. Fine, let's now quickly jump to the DFS solution also. Okay, DFS is nothing but stack instead of queue, so we'll just change the queue to stack, and then stack, and queue dot push instead of offer, instead of poll we'll say pop, and then queue instead of offer again we'll say push. Okay, and I'll just change this queue to, I'll say st. Okay, fine, st dot push, st dot pop, st dot is empty, st dot push. Let's run the code. Yeah, accepted. Now submit. Cool. Okay, so now this is DFS solution, we got it. Fine, now let's see a recursive solution also for this DFS approach. We just have to keep one thing in mind, we have to pass 2 params because we are always pushing 2 information, index and a step result, right? So instead of push, what will I do? I have to call the word break method recursively, you know, create a main method here. Okay, and we'll call this as DFS. Okay, we'll get rid of this node. We are going to return result, so we'll take this out from here, put it here. Okay, take this return from here and put it here. Okay, now dictionary. Okay, we'll take this also out from here and we'll pass the dictionary to this place. Okay, so instead of list, why I'm doing this, because when I am calling the DFS method, I don't want to pass the list again and again. Instead, I will be passing this set. Okay, so we'll call this set. I'll call this DICT. Yeah, DICT, because this DICT is used here. Okay, now I'll remove the stack. Okay, remove the while loop and pop, start, everything I will remove. Okay, because when I call this word break DFS recursively, that is what is getting done, pushed and popped, right? This one, yeah. Now because we are passing 2 params, so let's write int start and string step here. Start is here, this is good. Instead of node.step, we'll say step, right? start, this is fine, start, this is fine. Instead of step, instead of node or step, we can call this temp step, temp is empty, this is fine. Instead of now push, we will call this DFS method. Okay, S I and temp and DICT. Okay, I'll remove this step push. Okay, and because we have taken out the result, we'll pass the result also here. Let's say result. Okay, result dot add. Okay, fine, and we'll pass the result also here. Okay, this is fine, good. Okay, now we'll call this DFS from here, not return, word break. First is S, 0, empty, then the dictionary, and then the result. And also we have to remove this because it's a void method, void. Run. Fine, accepted, and now submit. Cool, nice. Thanks for watching, guys, and this is my channel. This is what I'm going to do, guys. I'm not going to do thousands of problems in the Leetcode in my channel, but I would like to, you know, target certain questions which are very, very helpful to, you know, open your thought process for cracking a coding interview. You can encourage me by subscribing or liking my videos. Stay tuned and see you next time. Until then, bye, take care.